Okay, what we're going to do is we're going to take a look at a trick you can do that demonstrates center of gravity, and you can do it with some household items. Okay, what I've got here is a fork and a spoon. It's good if these come from the same set, but if they don't, that's all right. You need them to kind of have a similar size and weight to them. And what I'm going to do is take these things and put them together as one unit. So I'm going to interlock the spoon and the fork and kind of put it inside there, so inside two of the prongs, so that you can get it to hold together as one unit. Now this unit is not a straight line, as you can tell, and because these handles go backwards and kind of have an angle to them, the center of gravity of this whole system is actually out here in open space. It's somewhere in this vicinity right here. Even though it's not part of the system itself, it's kind of like a picture frame. Right in the little picture frame, you would have a center of gravity kind of in the center where there isn't anything. Same with this, it's right here in space. So we're going to try to get this to balance using that center of gravity. So I'm going to take a toothpick. A flat one works the best, but it doesn't have to be flat. And I'm going to put it through this fork, and the first thing I'm going to try and do is see if I can find the balancing point where it doesn't tip side to side. Okay, it looks like it's about right there. Now I'm going to take it and set that toothpick on the edge of a glass. In this case I have a beaker, but it could be any cup, coffee mug, glass, anything like that. I'll move it around till I get it kind of fine-tuned and I find that center of gravity. Okay, now I take my hands away. You look at that. If you look at it from the side, from the top, it looks like it shouldn't stay there. It looks like it ought to fall. Okay, but what this demonstrates is that the center of gravity doesn't actually have to be on an object itself. The center of gravity happens to be right where that toothpick meets the edge of the glass. Out there in empty space, that's where the center of gravity of that entire system is. Now to further demonstrate this, I'm going to light the toothpick on fire. I'm going to light it from both ends. Maybe. There we go. Oh, let me try that again. Is it still going?
Yeah.
Okay, good. We'll just film the good and the bad. With me, there's a lot more bad than good. Okay, there we go. Good, got it back. I'll see if I can do this without making a mistake. Like that one on fire, and like that one on fire. Okay. Now, a couple of things are going to happen here. Number one, you see the fire goes out, and it does that every time it gets to the edge of the glass or to the edge of the silverware. Number two, it still doesn't fall, even with the toothpick not hanging off of both ends. Okay, that tells us that definitely the center of gravity happens to be right where the edge of the glass is. The reason the flame goes out is basically it's a heat sink. It's taking all the energy out of that little flame so that the reaction can't keep going. All that energy is sucked into the glass and into the metal, which is a much better conductor, and all the energy goes into that. Now, to further demonstrate this, I'm going to take this entire system off and put it on the edge of my finger. Notice you get the same exact effect. This is a lot of fun to do, say, in restaurants when you're waiting for your food. You can usually find all the materials to do it right there. People tend to walk by this and kind of give it a double take because they don't really understand what's happening. It doesn't look like it should stay that way. And that's an extra trick you can do with center of gravity.